right here I have question 3 from the test you took. Avery, you excited about this? And so let's read the question together. Which of these could represent the area of a square? Okay? Which of these could represent the area of a square? Now, what that's telling me is I've got to factor all 4 of these, right? And if it's a square, then I know all 4 sides are what? Equal. So I need something that looks like maybe y plus 2 times y plus 2, right? I need both binomials to be identical, don't I? If it's going to be the area of a square. Okay, so let's factor the first one. Now the first one, if I factor into 2 binomials, my factors of 6 that add up to be -4 are what? 1 and 6 won't do it. 2 and 3 won't do it. Hey, A is prime. You can't even factor A. So there's no way it could be a square, right? Let's look at B. The reason I know it's prime is 1 times 6. If I do 6 minus 1, that won't give me 4, right? And if I do 2 times 3, 2 plus 3 is 5, and 3 minus 2 is 1. So there's no way to get a factor of 6 that also adds up to be -4, right? Let's look at B. What factors of 4 will also add up to be -4? -2, -2. So I got y minus 2 times y minus 2. All right, so let's check it. -2 plus -2 does equal -4. And -2 times -2 does equal +4. And so there's your answer. The answer right there is B. Now, what most of you probably picked is what? C. Well, most of you picked D. And you thought, well, that's a difference of what? Squares, so it must be a perfect square, right? Mm-hmm. Well, y squared is a difference of squares, and is a perfect square, and 4 is a perfect square, and there's a minus in the middle. So this factors to be y minus 2 times y plus 2. But in order for it to be the area of a square, this has to be equal to this. And are they? No, because right here in the middle, I have a minus, and right here in the middle, I have a plus. Notice in B that they're both negative, aren't they? So in order for it to be the area of a square, the length and the width must be exactly what?
Alike.
Equal or alike, right. So on this one, it asks us, which of the following is a factor of the polynomial below? Right? Which of these 4 is a factor of this? Well, in order for me to tell that, what do I need to do with 4x squared minus 16x plus 16? Factor it. I need to factor it, don't I? So what's my first step to factor it? See if 4 will go into everything, and it does, doesn't it? Mm-hmm. And so I have 4 times, and I'm going to divide each term by 4, right? And when I do that, what do I get, Ivy?
X squared minus 4x plus 4.
Perfect. All right, so she factored 4 out perfectly, but now what's inside the parentheses can still factor. If it factors, it'll factor into 2 what? Binomials. I'm going to bring the 4 down. So I've got x and x. What is your factor of 4 that also adds to be -4? -2 and -2. Like that, right?
Right.
And so let's check it. Is -2 plus -2 equal to -4? It is. What's -2 times -2?
4.
+4. So you factored this perfectly. Now, let's further write 4. How could I write 4 differently as a prime? Would it be 2 times 2? Yeah, 2 times 2 times x minus 2 times x minus 2. Tell me this, is this right here the same as this right here?
Yes.
It is. Now let's see if can I get 2x minus 4 anyway? Yeah, what if I took this 2 and I distributed it here and here? Then I'd have 2x minus 4, wouldn't I? But it says up here, which of these is a factor? Well, that's a factor right there. Is there any way to get 2x plus 4? No, because If I took the 2 and distributed it here, there's going to be a minus in the middle in there. So B is not a factor. Let's see, can I get 4x minus 4? If I took this 4 and distributed it, it would give me 4x minus what? Yeah, 4x minus 8, right? So it's not a factor. Is there any way for me to get 4x plus 4? No. If I took the 4 again and distributed it, it'd give me 4x minus 8, wouldn't it? So the only one that's a possible factor is what? A.